So to solve the inverse of f of x, the first thing I need to do is, step one would be to write down the function in Cartesian notation, where y equals x plus 1, or x over x plus 1. So step one would be to take f of x and replace it with y. Step two is we flip-flop the x and y. So wherever there's an x, we flip-flop the x and y. And that's based on this graph here as I explain it. The x becomes y and the y becomes x when we do the inverse. So what I end up with is I have x is equal to y all over y plus 1. So now in the next step what I need to do is I just need to solve for y, and that gives me f inverse. So if I solve, well, it's not easy, but we can do it. So the next step is I need to make this equal y equals some stuff. In other words, I got to get y by itself. So this is a proportion. So let's think of this as x over 1. We're going to cross multiply, and I get y is equal to x times the quantity y plus 1. I'm going to distribute the x through the parentheses, and I get x comma 1, or xy plus x. Now if I take all the y values and put them on one side by doing minus xy to both sides, I end up with y minus xy is equal to x. This is the tricky part. If I factor out a y, I get 1 minus x equals x. Then I divide both sides by 1 minus x. And so I get y equals x over 1 minus x. And now you could write that a different way. You could say negative x plus 1. But your textbook just left it like this. Now what is that? That is f inverse. Now what does that look like graphically? Well, we could verify it. We could verify what it is graphically by plugging in the original function and its inverse. So my original function was this thing here. It was x divided by the quantity x plus 1, and then my inverse we found to be x divided by the quantity 1 minus x. Now this should reflect over the diagonal, and it does. Now here's an interesting thing. If I look at my table of values, it's a little tricky. Did I plug that in right? This is a little confusing, so let's look at the table of values. I want to kind of just demonstrate how this whole thing works. Let's take an x number. It doesn't matter. We'll pick any x number. I'll try to pick one that might be the most helpful. Well, we could do it graphically too. It's on the table of values. So if I hit trace and I let x equal 1. Well, if I let x equal 1, in other words, if I write this value down, when x equals 1, so we're starting with x equals 1, we plug that into the equation and it spits out 0.5 or 1/2, right? So now if I take that 0.5 and I plug that into the other equation, so I say 0.5, what should I get out? In other words, I'm going to let this be x equals 0.5. What should be the value here? No, it should be 1. Let's see. y equals 1. So I have a 1 here and a 0.5 here. And so what happens is whatever I plug in here, it becomes another number. But if I take that number and plug it into the inverse, I should get right back where I started from. Let's do that again. Let's go to the original function. This is my original function. Pick a small number. We'll plug it in. 2. So when x equals 2, my y, I get a funky y value, which is actually 2/3, right? That makes sense. So it's 0.666 repeating. Now, if I switch functions and I plug in 2 divided by 3, which is the 0.6 repeating, what will my corresponding y value be? 2, right? Because it undoes what was done. So if I enter that in, y equals 2. Does that make sense? Now, if that doesn't happen, you made a mistake somewhere.